Hi everybody, so today we're going to go do a quick run through our 3.0s before our FA. So first 3.0 is 4.3.1. This is looking at a polynomial and examining its characteristics just based off that expression. So I have my polynomial listed for you right here, and we are going to find two pieces of information from that polynomial. The first is the number of maximums and minimums. To find your number of maximums and minimums, there's a simple rule. All we have to do is the degree minus 1. So if I look back at my polynomial, this is in standard form. Our degree is our highest exponent. So in this case, our highest exponent is 5. So in the case of this polynomial, for our number of maximums and minimums, it would literally be 5 minus 1, which is 4. That means that there are 4 possible times that we have a high point or a low point on our graph. All right, now it's time for the little bit trickier part, which is end behavior. So for end behavior, you need to look at two things. You need to look at first the degree, and specifically in the degree, whether it's even or odd. The second thing you need to look at is the leading coefficient. And specifically with our leading coefficient, you need to decide if that is positive or negative. Okay, so let's look back at our polynomial. Our degree in this case is 5, which means that we have an odd degree. And our leading coefficient in this case then, that's the number in front of the term with the highest degree, is -2, which means that we have a negative leading coefficient. So there are basically 4 options between you either have an even or odd and positive or negative. If your degree is even, your graph will look either like this or like this. This top one is the positive case. This bottom one is the negative case. If your graph is odd, your graph is either going to look like this, and there could be more maximums and minimums in between there, or like this. And again, there could be more maximums and minimums there. And this top one is our positive case. This bottom one is our negative case. And I like to think about it that our positive case in the odd, it kind of looks like an increasing function, like it's positive. And our negative case in the odd kind of looks like it's negative function or decreasing here. The big difference between these two is that for even, your ends are facing the same direction. For odd, they are facing different directions. So then, from here, I'm going to go back to my characteristics. I had an odd function, and it was negative. So that means that I must be looking at this graph for this polynomial. Now again, we know from what we already did that there will be more like lumps and bumps in between those two ends. There will be more maximums and minimums, but we just care about that end behavior for this question. So now I know that it needs to look like this. Well, how do I describe this? We describe it using infinities. So your question is always going to ask you what is happening as x is approaching infinity and what is happening as x is approaching negative infinity. Well, these are just fancy ways of saying left and right. If I say as x approaches infinity, that's really asking what's happening as we go to the right. And if I say as x approaches negative infinity, that's really a fancy way of saying what's happening as x goes to the left. So what's happening on the right and the left of my graph? On the right, we can see on the right side of my graph that we are going down. And then on the left side of my graph, we can see that we are going up. Okay? So the way to write that fancy with our notation is that if we're going down, we say y is approaching negative infinity. And if we're going up, we say y is approaching positive infinity. And there you go. That was our tricky but doable end behavior answer. And that is 4.3.1. All right, let's look at 4.3.2. This one has two types of questions. You're going to be asked to find the perimeter of a shape and the area of a shape with polynomials. So for the perimeter, when we find perimeter normally with just regular numbers, all we do is add up the sides. We're going to do the same thing here with the polynomials. So I'm going to do 2x plus 9 plus 4x plus 1. Literally all I'm doing is adding up all the sides. Plus 7x squared plus 5x. Now I look at this and hopefully you see the same thing I do, that there are some like terms. So I have, it looks like, some x's that are like terms. I also have a couple constants that are like terms. This 7x squared cannot be a like term because it has that exponent. All right, so when I combine my like terms then, 2x plus 4x plus 5x, that's going to give me 11x. And 9 plus 1, that's going to give me 10. And then I still have that 7x squared, and if I want to write it in standard form, I'm going to throw that out front so that it's from biggest to smallest. And voila, we have our perimeter. All right, now let's look at our area. Here we have a rectangle. So if you have something other than a rectangle, you need to think of what that formula is. But we know for a rectangle, our area formula is length times width. So let's say that this is our length and this is our width. It really wouldn't matter which one you labeled which. All we have to do is multiply them. Now, the special thing about this, since we have polynomials, you need to remember to put those in parentheses. So I'm going to write my length times my width. Remember, when they're right next to each other with parentheses there, that means times. And then this is like a problem we've practiced a million times. We are now multiplying polynomials. So I do my first term times both my terms in the second set of parentheses. 2x times 6x would give us 12x. I'm going to give myself a little room. 12x squared. 2x times 3 would give me 6x. Then I do the same thing with this negative 4. Negative 4 times 6x, that will give me negative 24x. And negative 4 times 3, that will give me negative 12. Now I do have a couple like terms here. I got a 6x and a negative 24x. So at the very end, when I combine those, I'm going to have 12x squared minus 18x minus 12. Minus 12. And that would be my area. Woohoo! All right, let's look at 4.3.3. So for 4.3.3, we're basically looking at our exponent rules. We are just upping them a little bit here. So our exponent rules, let's do a quick recap of them. If you have two terms with the same base with different exponents and we're multiplying those, we add those exponents. If you have two terms or one base with two exponents and parentheses between them, you multiply those exponents. If you have two terms being divided with exponents, you subtract the top exponent and the bottom exponent. And then finally, this last one was our negative exponent rule, which says if I have a negative number, I just move it to the other side of our fraction and make it positive. All right, so now that we have those exponent rules down, let's tie them all together in this problem. So the trick is to take it step by step. Usually a good place to start is by simplifying the numerator. And I see some parentheses here. So that tells me that I'm going to distribute this 3 to both terms inside of our parentheses. We remember that there really is a little invisible 1 here. And we're distributing that exponent. So, and since there were parentheses here, that means we're multiplying. So that is going to change this to x to the 6th, y to the 3rd, and then I still have this z out front. My denominator I haven't done anything with, so I'm going to leave alone for now. It's still x to the 5th, y to the 8th. And now I get to simplify. So now, even though I have multiple things in the numerator and denominator, I can still use that rule. This is the quotient rule where I would subtract exponents, but we're only going to subtract things that have the same variable. So for example, I'm going to put the x's together, I'm going to put the y's together, and then we'll talk about that z in a moment. So x to the 6th over x to the 5th, we're subtracting. That would give us x to the 1st, because I did 6 minus 5. Y to the 3rd over y to the 8th, we are subtracting. When I do 3 minus 8, I'm going to get negative 5. And then this z, there is no other z in this problem, so I just leave the z alone. Now our last and final step, mathematicians hate these negative exponents. So to fix that, like I said before, we have to move that to the other side of our fraction and make it positive. So this would become x z over y, running out of room, y to the 5th. I've moved that y to the bottom and I've made it positive. The x and the z there were no issues with, so I leave in the numerator. All right, last but not least, we're looking at 4.3.4. Here's where I'm factoring using the GCF. So the first thing we have to do is find the GCF. And we have all 3 terms, so I need to find the GCF of all 3. So let's start with our number. Between 10, 30, and 50, our GCF here would be 10. That's not it though. We have all these variables. Don't forget about those. So now let's look at our x's. Remember our rule is that we go by the smallest exponent. So I have a 6, a 3, and a 4 for my exponent of x's. Our smallest exponent is 3. Then our y's, I have a 7, a 9, and a 4. Our smallest exponent here would be 4. Then for our z's, I have a z here. Ooh, remember there's an invisible 1. I have a z here, a z squared here. I don't have a z at all here. So if one of my terms doesn't have a z, that means I cannot include it in the GCF. So that's it. 10x cubed, y to the 4th, that's my GCF. Now the 3.0 part of this is putting the leftovers in parentheses. So I'm going to give myself a good amount of room. And what we're going to do is we're going to look at each term and divide out our GCF. So let's start by dividing these coefficients. 10 divided by 10, that just gives me 1. And then let's think about this. We had 6 x's. We took 3 out. That means we're going to have 3 left in this term. I had 7 y's. I took 4 out with my GCF when I factored. So that means I have 3 y's left. Then I had a z. I didn't take any z's out here at all. So that means my z is just going to stay there. That is definitely left over. That was my first term. Now I'm going to move on to my second term. So I'm going to put a plus. 30 divided by 10 gives me 3. 3. I had 3 x's. I took 3 out. That means I have no x's left. So I'm not going to include that in my leftovers because there are no leftovers. Now I had 9 y's. I took 4 out. That means I have 5 left. And again, I have a z where I didn't take any out, so I'm just going to leave the z in there as well. All right, we did 2 terms down to the last one here. So I have negative 50 divided by 10. That gives me negative 5. I had 4 x's. I took 3 out. That means I have 1 left. And you can choose to put the 1 there or not. Remember that exponent, if there is not one listed, it is assumed that there's a 1. I had 4 y's. I took 4 out. Oh, that means I'm not going to have any y's left over. So literally this term is just 5x. So once I've gone through all of my terms here, I am done. I have factored using my GCF. I hope this helped you guys remember some of those 3.0s. If you still have questions, feel free to reach out to me for help.